Alright, today we are starting chapter 7, which is entitled Radical Equations and Inequalities. Excuse me. So the first one we're going to be dealing with is operations with functions. A lot of this stuff we should have done before. We're just looking to add, subtract, multiply, and divide functions, and to find the composition of functions. So we're just going to go through and do some of these. And when I say divide, I don't mean synthetic division. We are finished with that just for a little bit. But we will get back to that before the end of the year, but not today. So for now, the operations with functions, we are looking at, if it says f plus g of x, all you're doing is adding the two functions. You're just adding like terms. So you can see my example there of x plus 2 plus 3x. It's x plus 3x is 4x, and then you just add the 2. Same thing with subtraction. X minus 3x is a negative 2x plus 2. When you multiply, we know how to do that. You distribute, so 3x squared plus 6x. And then when you divide, for now, we're just going to write it as a division problem. So as x plus 2 divided by 3x. We're not going to worry about actually dividing that out. Even though we do know how to do that, for these ones, we're just going to be rewriting it. We're not actually going to be doing that. So let's go ahead and take a look at how to do some of these, or looking at examples of some of these. So for the first one, we want to add f plus g of x. So what this means is I'm really taking f of x and I'm adding it to g of x. So for this, f of x is just x squared minus 3x plus 1, and g of x is 4x plus 5. So I'm adding that whole quantity, 4x plus 5. Now because it's adding, nothing happens with the signs. There are no other terms for x squared, so it just turns into x squared. Negative 3x and 4x is a positive x, and 1 and 5 is 6. We're not looking to factor, we're not looking to solve. All we're doing is adding the functions. So let's go ahead and subtract them. So for this one, we're taking f of x minus g of x. So we get x squared minus 3x plus 1 minus the quantity 4x plus 5. Now if you remember, this is where you want to distribute that negative sign. So we're going to end up with x squared minus 3x plus 1 minus 4x minus 5. Make sure both pieces get that subtraction sign. So x squared again doesn't have anything. So negative 3x minus 4x is a negative 7x. 1 minus 5 is a negative 4. So that's our new function when we subtract the two given functions. So this time we have two different functions, and they're asking us to multiply and divide these functions. So multiplying, we did that in the last chapter. We know how to distribute that. So some of this is review from the last chapter. So this is taking f times g. So we're going to take x squared plus 5x minus 1 and multiply that by 3x minus 2. So I distribute this to each thing. So 3x times x squared is 3x cubed. 3x times 5x is 15x squared. 3x times negative 1 is a negative 3x. Negative 2 times x squared is a negative 2x squared. Negative 2 times 5x is a negative 10x. Negative 2 times negative 1 is a positive 2. Combine like terms. There's nothing else for the cube, so we just have 3x cubed. 15x squared minus 2x squared is a positive 13x squared. Negative 3x minus 10x is a minus 13x plus 2. And again, we're not actually going to divide this out for the f divided by g. We're just going to rewrite this as x squared plus 5x minus 1 divided by 3x minus 2. I'm not worried about you guys dividing that out. We did that last chapter. So for now, just leave it as a fraction form. It's a way of writing it. It's kind of remedial right now because we've already done more complex versions of that. The composition of functions is really when you put one function inside of another function. So this is something we should have seen back in Algebra 1. I know it's been a little while since that, but we should have seen this way back then. And so when you look at this, you say that open dot, you say f of g of x. And what that means is you're putting g inside of f. So you're replacing all of the things. So just like you'd plug in a -4, except this time we're plugging in a whole thing. Again, we've done this before last chapter. We're just rewriting it and calling it something else this time. Now, it's different when you look at doing f of g of x when you have functions like this. So what we're going to do is, remember, this is the x and the y, which is the domain and the range. So what I'm going to say is the domain of f, let me write it small, domain of f, range of f. So I'm just going to list them. So the domain, we have 7, 5, 9, 11. The range of f then is 8, 3, 8 is already there, so we don't have to repeat it, and 4. Excuse me, I've done this backwards. You want to go domain of g first, because you're putting g inside of f. I had this backwards. My apologies, guys. So excuse me, go domain of g and range of g. So domain of g is 5, 3, 7, 9. The range of g is 7, 5, 9, 11. Now our hope, so the 5 points to the 7, the 3 goes to the 5, the 7 goes to the 9, and the 9 goes to the 11. Now our hope is that the range of g matches the domain of f. So when I look at the domain of f, I'm hoping those are all the same, which they are. We have 7, 5, 9, 11. I want those all to match, and they do. So this is continuing over, and then we look at the range of f. So now my range of f is 8, 3, the 8 repeats, and 4. So then in the domain of f, we have 7 points to the 8, 5 points to the 3, 9 also points to the 8, and 11 points to the 4. So we follow our paths, and those are our new answers. So when I'm over here writing f of g, I follow the path. I started with a 5, so I'm going to write a 5. I follow it through to the 7, and it leads me to an 8. So you're kind of using this middleman column to get you from one point to the next. So in the next one I have 3 is what I'm starting with. So I start with a 3 in G, it points me to the 5, which continues in F, and then it goes to another 3. The next one I start with a 7. It points me to the 9, which points me back up to the 8. And then we have a 9, which points me to 11, which points me to 4. So my new points, my f of g, is going to be 5, 8, 3, 3, 7, 8, and 9, 4. Now as you can imagine, what we're going to be doing when we go g of f is we're going the opposite direction. So once you get that all down, we're going to have to erase all of this, because we want to go the other direction now. We want to start with f. So really what I was doing the first time was the second half of this. And myself backwards. So this time, whichever one comes second, you're putting first. So the domain of f, then we go into the range of f. Then we're hoping that the domain, or the range of f matches the domain of g, which will then point us to the range of g. And that will then lead us to g of f. So the domain of f, once again, is 7, 5, 9, 11. The range of f is 8, 3, 8, 4. The domain of g is 5, 3, 7, 9. The range of g is 7, 5, 9, 11. Now with this one it's a little different because we start over here with the domain, we follow through. So the 7 in f points to the 8. The 8 doesn't match up, it's a dead end. There's nowhere for this one to go. So this one doesn't lead us anywhere. There is no point associated with it coming out the other side. So then I go to the 5. The 5 leads to the 3. The 3 does have a match. In G, the 3 points me to a 5. So I started with a 5, and I ended with a 5. So you can only make it through if there's something to match here. So the 9 points me to the 8. Again, the 8 is a dead end because there's nothing to go out of there. So the 9 is also a dead end. The 11 points to a 4. The 4 has nothing over here in G to pull it. So the 11 is a dead end. The only point that made it was the 5, 5. Nothing else there could make it because nothing else overlapped between the range of F and the domain of G. Something in here has to match. So that might happen sometimes. So it doesn't mean there's no solution or you don't want to automatically, jump to that conclusion, but you want to go through and follow that chart throughout. Okay, now this is what we're going to see more often. So we do some of those chart ones, but the ones that we're going to see more often and the ones that are more important are doing them this way, algebraically. Sometimes we're given a list. More often, we're given functions. And we want to be able to do them this way. So if I say find f of g of x and g of f of x for f of x plus 3 and g of x is equal to x squared plus x minus 1. So f of g of x, when I rewrite that, that's really saying f, remember the second one is the one on the inside. So what that means is I'm putting g inside of f. So all I'm going to do first is replace g of x. I work from the inside out. So we have x squared plus x minus 1. And now we've seen stuff like this before, where I want to put this inside of all the x's in f, which for me is just the 1, and then we add a 3 on the end. Combine like terms if you can. Negative 1 plus 3 is a positive 2. Let's go the other direction. If I have g of f of x, remember this is really saying g of f of x. I want to work from the inside out, so replace the f. G stays out here, so it's x plus 3. And that's telling me everywhere there's an x in G, I'm replacing it with the quantity x plus 3. So in G, I'm going to have x plus 3, the quantity squared, plus x plus 3 minus 1. Square that. Remember, that does not distribute. You FOIL. X squared plus 6x plus 9 plus x plus 3 minus 1. Combine like terms. X squared, 6x and x is 7x. 9 plus 3 is 12, minus 1 is 11. Notice they do not give you the same answers. Each of these are going to give you separate answers. So you can't just say, oh, well, what I got one way is what I'm going to get the other way. They are two separate things. Now, they want us to, I'm going to leave this up here for a second because all they're asking us is to evaluate each of those for x equals 2. What that means is they just want you to plug in 2 for each of these answers. So for this one, you would write that f of g of 2. So if you see it written this way, that means find this and then plug in 2. So when I plug in 2, we're going to get 2 squared plus 2 plus 2. 4 plus 2 is 6 plus 2 is 8. Same thing over here. We're going to have g of f of 2. So I plug in 2. We get 2 squared plus 7 times 2 plus 11. 2 squared is 4 plus 14. It's going to be 18 plus 11 is 29. Again, two different answers. And that's it for this first section. That is all we're going to cover. So it's 388, 15 to 27, the odds. So our calendars are going to be a little off both because I didn't post this the first night, and with our pep rally, our calendars are just going to be a little off. So we will update our calendars and we'll kind of talk through this in class.